Question 19. Oliver records the distance from London to each of 8 cities in the USA. He also records the times taken to fly from London to each of these cities. The scatter graph shows the information. Now, as you can see, I've already completed the question, but the first part says, Chicago is a city in the USA. It's 4,000 miles from London. By drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. So it tells me to draw a line of best fit. Here is my line of best fit. I've drawn it. Now, need to make sure it goes through most of the points, and as you can see, that the points are kind of very evenly spaced around either side of the line. So, the distance is 4,000 miles. So, along the distance, which is on the y-axis, I find 4,000. And I need to draw a line across up to my line of best fit. And I'm going to draw a line straight down onto the x-axis. And if I was to read that straight off the scale, I can see that is 480 minutes. Now, you didn't have to get exactly 400. You could have had 480 to around 500. But as long as it follows your line of best fit, then you could have got the right answer. Okay, so 480 is my answer for that one. Why is it only an estimate? Well, it's only an estimate because A, it's a data sample. The line of best fit can vary because the flights might not be, or the distance, the mode of travel might not be direct. The flight might not be direct. So calculate the gradient of your line of best fit. So to find the gradient, we just needed to know that it was the distance divided by time. So you get 1 mark for realising that it's y divided by x, or distance divided by time, because the y is distance and time is on the x-axis. So from this, I can draw on my straight line a triangle anywhere. Doesn't matter where it is, it just needs to be quite nice to be able to read off the graph. So I've drawn my triangle here because I can see that that goes straight up to 4,500 from 4,000. So I know the change in y, the change in the distance, goes from 4,000 up to 4,500. So that change is 500. I can then see that if I were to complete that triangle, it goes from here, which is about 495, 480, roughly. It's about 55, I'd say. About 55 there. And you could have had any values for this as long as it's read off of your line of best fit. So my calculator, the distance, which was 500, divided by 55, which is time, equals 9.1. 1 mark for getting this bit, second mark for getting somewhere between, you probably need it to be between 9 and 10. So give an interpretation of the line of best fit. Well, hang on. I know that distance divided by time equals speed. So the gradient of this line is the speed that they travel. Question 20. Rotate shape S clockwise, centre 5, 4. Label your image T. So, you're probably going to need tracing paper for this, but if I attempt to do it with just my paper, we'll see how we get on. I'm just going to draw my shape out. And then I need to recognise that my centre was 5, 4. So, 5 along, 4 up, here's my centre, so that's where I'm going to rotate it from. And if I can place that hopefully back on my page reasonably set, and there's my centre, I'm basically going to place my pen on that centre and rotate this piece of paper 90 degrees. And then I'm going to attempt to draw out my triangle again. And hopefully that's, yeah, it has. Hopefully it's come through on your page. Now you can't see it on here, but I can see some very small indents on my page. But if you remember to place your pen on the centre, which was 5, 4, you should hopefully be able to get there. So I know it's difficult for you to see, but I can just about see it. Here, and so here is my new triangle, and if I was just to join up my lines, just remember to place your pen on the point there. Okay, so describe fully the single transformation that maps it on to point S. It's a rotation 90 degrees at the centre 5, 4.